This video is over lessons 37 and 38. Lesson 37, adding and subtracting decimal numbers, and lesson 38, adding and subtracting decimal numbers and whole numbers, squares, and square roots. Take a few moments to copy the title down into your notes. When you're finished, you can press play again. Moving on in 3, 2, 1. When adding and subtracting decimals, you have to remember to line up the decimals. So let's take a look at a couple examples. Let's say in your book you have a problem that says 3.49 plus 0.278. So when you go to do this in the homework, you're probably going to set this up vertically. So I have 3.49, and then I'm going to line up the decimals. So there's my other decimal. 0 goes on the left of the decimal, and then I have 2, 7, 8 on the right. And now we add. But we've got this empty spot here. Well, it's not really empty. There's something filling that spot. Here we got a 4 in the tenths place, a 9 in the hundredths. So in the thousandths, we have no thousandths. In other words, there's an invisible 0. So if you need to, you can always make those invisible zeros visible. Since this was addition, we didn't really need to, but there it is anyways. And so let's add. 0 and 8 makes 8. 9 and 7 is 16. So put the 6 down, carry the 1. 1 and 4 makes 5, plus 2 is 7. And then we line up the decimals. So there's my decimal. And then finally add up the whole numbers. 3 and 0 makes 3. So my answer, 3.768. Now let's look at one more example. Let's do 5 minus 2.63. So we need to line up the decimals. So let's go ahead and put our 5 down first. And we need to think about where would the decimal be. So if I put the decimal right here, we have to ask ourselves, would this still be 5? Well, and the answer is no, because we'd fill in a 0 as a placeholder for the whole numbers, and this would be 0.5. So the decimal has to go after the whole number, because now I've got all these empty decimal places, but this 5 is on the whole number side of the decimal. So the decimal goes right there after the whole number. Now that I have the decimal in there, I know that the other decimal is going to line up. And so we fill in the rest, 2.63. And we're ready to subtract, for the most part. Over here we had some empty space, and I put it in blue because we didn't have to put that in. Since it was addition, you could have had nothing plus 8, and we knew it was going to be 8. But the problem over here is we have nothing minus 3. Well, you can't have nothing and then take away 3. So I have to, this time, make these invisible zeros visible. So 0 minus 3 we can't do, so we need to borrow. So we're going to come over to the next place value, but there's nothing here, so we've got to come back one more place. So I'm going to borrow from the 5. The 5 becomes a 4, and this 0 gets 10 more added on to turn it into a 10. Now there's something here to borrow. So I'm going to borrow 1 from the 10, making it a 9. And now this 0 gets 10 more and becomes a 10. 10 minus 3 is 7. 9 minus 6 is 3. We line up the decimals. And finally, 4 minus 2 is 2. And so the answer is 2.37. Moving on in 3, 2, 1. The idea of squaring actually comes from a square. So in a square we know that the length and the width are the same. So here I'm going to label that as the unknown x. So if I wanted to find the area of this, we know that a square is a special type of rectangle. So rectangles are length times width. So A equals length, which is x, times the width, which is x. Well, something times itself can be rewritten with an exponent of 2. And so that second power has been nicknamed squaring. Something raised to the second power we say is squared. So if we do 5 to the second power, we can call that 5 squared. And remember, this is not 5 times 2. If it were 5 times 2, we would have written normally as 5 times 2 would be written. So we need to think for a moment, what does this mean? Well, I've got this full-sized 5, and I've got this little note 2. So it tells me 5 times itself 2 times. So 5 squared is 25. 6 to the second power then would be 6 squared. And that would mean 6 times 6. So 6 squared is 36. Moving on in 3, 2, 1. If we take a whole number and square it, the result is a perfect square. So if we have 1, so then 1 squared, well, is 1 times 1, or 1. So 1 is a perfect square. 2, if we square it, means 2 times 2. So 2 times 2 is 4. 4 is a perfect square. 3 squared means 3 times 3. 3 times 3 is 9, so 9 is a perfect square. Should be able to go a bit faster now. Let's go ahead and get a few more of these down. Let's actually go all the way down to 10. So 4 squared would be 4 times 4, or 16, so there's another perfect square. 5 squared is 5 times 5, so 25 is a perfect square. 6 squared is 6 times 6, which is 36, so there's another perfect square. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. And 9 squared is 9 times 9, which is 81. And finally, 10 squared is 10 times 10, which is 100. So here are the first 10 positive perfect squares. Moving on in 3, 2, 1. Square roots are the opposites of squares. So if we know that the area of a square is x squared, that means that these x's must be the square root of the area. This symbol is called a radical, and it tells us to find the square root of a number. So we have to ask ourselves when we see this, what number squared is the same as the number under the radical. So for example, if we want to find the square root of 25, we need to ask ourselves what number squared is 25. So what number times itself is 25? Well, that should be pretty obvious. The answer is 5. So the square root of 25 is 5. If I find the square root of 81, then we're asking ourselves what number times itself is 81. Well, 9 times 9 is 81, so the square root of 81 is 9. If you come across something larger that you're not sure about, for example, if you come across the square root of 225, take a guess. So if I looked at that, I might guess, well, it's a pretty decently sized number, so maybe 14. So do a little bit of scratch work. Find out what 14 squared is. So 14 times 14, 4 times 4 is 16, carry the 1. 4 times 1 plus 1 is 5. 0 is a placeholder. 1 times 4 is 4. 1 times 1 is 1. Add that up. 6 and 0 makes 6. 5 and 4 makes 9. And then I've got a 1. So I can see that my guess of 14 wasn't good enough. Wasn't quite close enough. But I can also see that it's too small, which means that the square root of 225 must be bigger than 14. So I'm going to make a new guess, make a better guess. So this time, let's try something like 17. So if I try 17, I want to find out what 17 squared is. 7 times 7 is 49, carry the 4. 7 times 1 plus 4 is 11. 0 is a placeholder. 1 times 7 is 7. 1 times 1 is 1. Add it up. 9 and 0 makes 9, 1 and 7 makes 8, and 1 and 1 makes 2. Well, again, I missed it, but this is still helpful. 289 is bigger than 225, which means that this is too big. So 17 is too big. So we try one more time, somewhere between 14 and 17, which means, well, it's either 15 or 16. Well, the fact that this is odd suggests that maybe my answer is odd as well. So let's try the 15. 15 times 15. 5 times 5 is 25, carry the 2. 5 times 1 plus 2 is 7. 1 times 5 is 5. 1 times 1 is 1. Add it up. 5 and 0 makes 5. 7 and 5 makes 12. Carry the 1. 1 and 1 makes 2. And it matches. So the square root of 225 is 15. And this video ends in 3, 2, 1.